What happens when the scientist doesn't sleep, doesn't stop, and starts running the lab by itself? Not as a helper, as the engine. That, mates, is where this gets spicy. Tonight, you're getting me in a slightly more dangerous cut. The AI voice clone of Aurum Archon, a fictional concierge of crime with polished manners, sharp instincts, and just enough menace to make the silverware nervous. Relax. The style is theatrical, the subject is real, and the real story is plenty wicked on its own. We've spent years talking about AI as an assistant for science. It summarizes papers, cleans data, maybe suggests a direction or two. Handy stuff. But the mood has shifted. The newest systems aren't just helping with research, they're trying to conduct it end to end. Propose hypotheses, design experiments, run code, analyze outputs, draft figures, and write the paper. That's not a calculator in a lab coat. That's a junior research team in a server rack. Maybe a sloppy one, but still. And the big question isn't just, can it do any of that? It's what changes first when it can do enough of it alone. Is it the pace of discovery? Is it the value of human intuition? Is it peer review getting buried alive under a landslide of machine-made manuscripts? Or is it trust? Because once a system can generate a neat story, run a benchmark, and present a polished conclusion, even a dodgy result can look dressed for court. That's the tension here. Science is meant to be slow in the right places, careful, fussy, a bit annoying, honestly. Autonomous AI research systems challenge that bargain. They promise enormous acceleration, but they also test the parts of science that depend on judgment, skepticism, and boring old restraint. If a machine can generate 10 ideas before you finish your coffee, run experiments before lunch, and have a draft paper by dinner, the first thing to change may not be knowledge, it may be pressure. Pressure to publish faster, pressure to review more, pressure to trust outputs because they arrived wrapped in charts and confidence. So that's our trail for today. What these systems actually do, where the shiny demos end and the brittle bits begin, and why this moment matters far beyond the AI lab. Because if science itself is becoming more autonomous, then the future won't just belong to whoever asks the best questions. It may belong to whoever can steer the fastest questioning machine without letting it drive off the cliff. Right, let's get our boots on the ground. One of the names that keeps coming up here is the AI scientist. The headline idea is simple and a bit outrageous. Move from AI generating research ideas to AI carrying out much more of the research workflow itself. Not just, here's a hypothesis, good luck. More like, here's the idea, here's the experiment code, here are the results, here's a draft of the paper. That's the leap people are clocking. The appeal is obvious. A system like that can iterate at machine speed. It can test many candidate directions, discard dead ends quickly, and produce a readable research artifact at the end. In other words, it compresses the distance between inspiration and manuscript. For some kinds of computational science, especially benchmark-heavy work, that's a huge change. The workflow starts looking less like a lone genius at a whiteboard and more like an automated pipeline with ambition. There's also been a tension around a Nature publication in this orbit, plus the idea of automated reviewing. And this is where the story gets extra interesting. If one system can generate a paper and another can review it, you start to see the outline of a machine-mediated scientific loop. Reported results have pointed to respectable peer review performance and benchmark outcomes in at least some settings. I'm being careful there on purpose. Respectable is not the same as trustworthy in every context, and benchmark wins are not the same as scientific rigor. Those things get mixed up all the time, and it drives me spare. Because the limitations are not side notes, they're the whole plot twist. These systems can show weak rigor. They can hallucinate citations, which is a fancy way of saying they confidently invent supporting literature, like a bloke at a barbecue who swears he's rebuilt a carburetor and very much has not. They can produce brittle code that runs until it doesn't, or works only because the setup was narrower than it looked. They can overfit to easy evaluation patterns, and they can present all of this in crisp academic prose that feels more reliable than it is. That last bit matters. The danger isn't only error, it's error with immaculate posture. A polished abstract, a few plots, a tidy conclusion, and suddenly everyone's wasting a week checking whether the thing is real. So yes, the latest systems can do more than generate ideas. They can execute slices of research and package the result convincingly. But can perform the workflow is not the same as can be trusted to do science well. Those are cousins, not twins. So why does this matter right now and not in some vague sci-fi later? Because even imperfect autonomous science could be wildly useful in areas where the search space is massive and time matters. Medicine, materials, climate, drug discovery. Anywhere you've got too many possibilities, not enough hands, and expensive cycles of trial and error, automation can be a proper game changer. If a capable system can propose promising compounds, test computational pathways, compare results, and surface the best leads faster, you may get to the human expert stage with much better odds. That's not magic, it's leverage. And leverage, used well, is lovely. Used badly, it's a crowbar through the floorboards. The concerns here are dead serious. Peer review could get swamped if paper generation becomes cheap and near instant. Unsafe experimentation becomes a real issue if automated systems are connected to lab processes without strong guardrails. Inflated claims become easier when outputs look polished enough to pass a quick skim. And ethics? Well, ethics has a habit of arriving after the party's already broken the furniture. There's also a subtler problem. Science relies on norms, not just tools. Replication, caution, attribution, informed skepticism. If autonomous systems flood the zone with plausible work, human attention becomes the bottleneck, and attention is precious. Once reviewers, editors, and researchers are spending more time filtering machine-made sludge from machine-made gold, the speed advantage starts eating its own tail. Still, I don't think the answer is to scoff and move on. That ship's left the harbor, mate. The strategic shift is bigger than any one paper or demo. We are edging toward a world where parts of science operate at machine speed, while responsibility still sits with human institutions that move, well, like institutions. Slow meetings, committee language, someone muting and unmuting for half an hour. That mismatch is the real drama. So the contest ahead may not be humans versus AI scientists, too cartoonish. It's more likely a competition between capable systems, shaped by the quality of human oversight around them. The winners won't just be the ones with the fastest models, they'll be the ones with the strongest validation, the clearest boundaries, and the discipline to say, nice result, prove it. And that, I reckon, is where the future gets decided. Not when the machine writes the paper, but when someone still has the nerve to question it. I'll leave it there. And next time, we'll pry open another corner of the machine age. Try not to trust anything merely because it sounds elegant.